I'm Rene Ritchie, and Apple has just announced the A14 Bionic system on a chip for the brand new iPad Air. And whether or not the new Air excites you, that A14 sure as hell should, because it's almost certainly going to be the exact same chip that we're going to get in the iPhone 12 as well, and the same IP generation as we'll be getting in the first ever Apple Silicon Mac. Yeah, you knew there was a reason Apple only teased us with the Air for now, but isn't actually letting us get our hands or our favorite geeky benches on it until next month. Still, we already know quite a few things about the A14, and more than you might think, and I'm going to break all of that down for you right now. Sponsored by Brilliant. Quick, YouTube tells me 70% of you watching this video still haven't subscribed. So hit that button and that bell right now, and that way you won't miss any of the iPhone, iPad, or Apple Silicon videos I have coming your way and soon. As much as we all may want the new iPhones and want them yesterday, if not sooner, it is kinda low-key fitting that this wretched worse than Game of Thrones Season 8 of a year prompted Apple to announce the A14 with the iPad Air instead. It's nostalgic even, given a decade ago this year, Apple debuted their first ever branded silicon with the A4 inside the original iPad, a full 6 months before the iPhone 4 got it as well. And since then, Apple's vice president of silicon, Johnny Srouji, has become a senior vice president. The A series has gone from 32 to 64 bits, from licensing ARM and Imagination Designs to licensing architecture and making their own custom cores, from secure enclaves and neural engines, and literally from 0 units to shipping over 2 billion chips. Silicon chips, not like barbecue or salt and vinegar or anything, though that's probably how Intel is feeling right about now. But I do think that's largely because Apple isn't and doesn't have to act like a merchant silicon provider, like Intel or even Qualcomm. And the A14, in both the new iPad Air and upcoming iPhone 12, is kinda the perfect example of that. And I'll get into all the specifics in a not at all thermally maxed minute. But this part is important to understand. Apple just doesn't have profit and loss on selling chips. They don't have to balance the competing demands of multiple buyers building very different kinds of devices. And they can work multiple years out with the other teams inside Apple, from the hardware engineering and software teams to industrial and even human interface design. And sure, marketing. And that means it's not just that they only have one customer. They also only have one real job: to run iOS and its many variants, and now macOS, and every app on every one of those platforms just faster than anything else in the world. And sure, some might push back on that and say, well, with all the new devices Apple keeps rolling out, doesn't that mean the silicon team effectively now has multiple customers just within Apple, like the iPhone and the iPad, the Apple Watch and the AirPods, and now soon the Mac? But I think Apple's done something pretty canny. Not only have they been working for years on scaling iOS into everything from watchOS to tvOS and bringing key characteristics of iOS to macOS, they've also been working for just as many years, maybe more, to create a silicon architecture that they can scale from the iPhone down into the Apple Watch and up into not just the iPad Pro, but now soon the Mac as well. And I mean, the Apple Watch S6 system in package is getting the iPhone 11 A13 system on a chip core architecture this year, which is just silly. It's silly, especially given how non-existent real wearable silicon competition even is at this point. And sure, the new iPad Air might not tickle the A14 ISP, or image signal processor, anywhere nearly as much as the iPhone 12 will, because it doesn't have the same camera system, and because most people simply don't use cameras the same way on iPads as they do on iPhones. And equally, sure, given, the iPad Air will have a bigger thermal envelope than the iPhone, which will be better for the kinds of graphically intensive creative apps people tend to use more on the iPad than they do on the iPhone, things like 4K video editing. So yeah, absolutely. Maybe the ISP is a little OP for the iPad, or the maximum perf a little extra for the iPhone. And when these chips hit other products like the Apple TV or get scaled down for the Apple Watch, there'll be other trade-offs. But in general, I think the efficiency, The savings on time and talent by having everything so tightly integrated and aligned, it seems to really, really pay off for Apple. Because they're not doing what other chip companies are doing either. Not just ramping up power draw or throwing extra cores to brute force performance increases at the expense of efficiency. They're increasing performance and efficiency pretty much at the same power and pretty much in the same thermal envelopes. And that brings us to how. So just like the A12 was the first 7 nanometer chip to go into production, the A14 is the first 5 nanometer chip. And if those sound like just Hank Pym, like Ant-Man and the Wasp, like quantum realm level numbers, well, kinda. I mean, not yet, but we're getting really close. In fact, rumor has it Apple has bought out just all of Taiwan semiconductor manufacturing companies, all of TSMC's 5 nanometer capacity, at least for now. Like, just nobody else is getting any of it, not for a while. And what that gives Apple is a huge advantage when it comes to density. See, a system in a chip, an SoC, inside an Apple device like an iPad, especially like an iPhone, is space constrained. But by going from 7 nanometers down to 5 nanometers, that lets Apple get more transistors into that space, up to 1.8 times more, or around a 45% area reduction based on TSMC's claims. And yeah, we'll have to wait for the inevitable teardowns and die shots to see exactly how Apple's balancing everything out. But we do already know that the A14 packs in 1.8 billion with a B transistors, and that's up from the A13's 8.5 billion, or, just over 3 billion more transistors to spend on existing compute engines and new feature sets, starting with the CPU. Back with the A10 Fusion and the iPhone 7, Apple introduced the idea of, people get snappish when I call them big dot little, so I'll just say performance dot efficiency cores. Basically, as chips got better and better performance, they used more and more power, even for tasks that didn't require that much power. So the idea was, as you increased performance on one side, you'd introduce something else to fill the efficiency gap on the other. And that's what the A10 did. It had smaller Zephyr cores that could handle normal tasks without being so power hungry. And larger Hurricane cores that could handle more demanding tasks, but at the cost of being more power hungry as well. But they were fused together. They had to work together. Hence the Fusion name. As part of the A11 Bionic in the iPhones 8 and 10, and yes, I said iPhones, West Wing me, Apple kept the efficiency.performance architecture, but ditched the Fusion. So the quote-unquote big Monsoon cores and the little Mistral cores could work separately or together as needed. Hence, well, not the Bionic name. The Bionic name just has to come from someone on the Silicon team being an obviously huge Steve Austin fan, and not the Stone Cold one, the $6 million one. Never mind. Wikipedia it. But they've managed to keep that Bionic name going on 4 generations and years now. So yeah, talk about your architectural efficiencies when it comes to branding as well. Anyway, the A14 Bionic has a 6 CPU core with 2 high-performance Firestorm cores and 4 high-efficiency Ice Storm cores. And yet, Apple's continuing their habit of making any given generation's efficiency cores much more performant, and performance cores much more efficient, because those things are just inextricably linked. Apple said the A14 is 40% faster than the A12, and doing some quick back-of-the-keynote math, the A13's Lightning and Thunder cores were 20% faster than the A12's Vortex and Tempest cores, though I think AnandTech claimed Apple was just underselling that a little bit. Anyway, divide by 0, carry the 1, that should make the A14 again 20% or so faster than the A13. Which will, of course, no doubt, make the Moore's Law is deadheads among us just eye roll so hard. But hey, Apple's still kicking away at that Moore corpse as much as anyone in the industry. Just using that very wide architecture, optimizing it for efficiency, and keeping those cache sizes just extra generous while doing it. More recently, Apple started making their own custom GPUs as well. With the A14, it's again a 4-core graphics engine, which they say is 30% faster than the A12. And the A13 was 20% faster than the A12. So again, C-Tech astronomy that math, and we get 10% over the A13, which, legit, for sure, isn't as much as the CPU gains. But I also have a sneaky suspicion Apple is leaning even more heavily, if anything, on the other elements of their custom silicon now. But First GPU things first. The A14 maintains Apple's focus on efficiency there as well. They want to be able to deliver most tasks most of the time at the lowest voltage and frequency, but still be ready to ramp up, to spike up even if and when you need it for that performance. That lets them preserve as much battery life as possible while also providing really good sustained and peak performance. And I think the whole approach is something a lot of people are staring at, awkwardly maybe, but unabashedly, to see how Apple scales up GPUs for Mac silicon, especially Pro and desktop Mac silicon, and, of course, Pro desktop Mac silicon. So back in 2017, Apple introduced their first ANE, or Apple Neural Engine, as part of the A11 Bionic. Its sort of big showcase feature back then was Face ID, the ability to scan facial geometry and just figure out if you were you, even if the exact way you styled you varied every day, even during the day. It was something that I think showed how Apple Silicon interfaces with the rest of the company. You know, coordinating with the hardware team working on those true depth cameras and the software team working on those adversarial neural networks. 2, 3 years even before the feature ever hit the stage. Literally putting AI into the chip at the silicon level well before people were accusing Apple of missing out on the whole buzzword style AI revolution completely. But, you know, far be it for me to tell the pundits how to do their jobs. And that original proto-neural engine in the A11 Bionic could do 600 billion operations per second. This new neural engine in the A14 Bionic, which seems to be just doubling as fast as all of our shelter-in-place sourdough starters, is now up to 16 cores and 11 trillion with a T operations per second. And for those calculating along with me at home, that's twice as fast as the 8-core ANE found in both the A12 and the A13. But Apple has also been optimizing the entire system on a chip, the entire SoC for machine learning, including the CPU and the GPU, and starting last year, introducing new custom accelerators called AMX blocks for accelerated matrix multiplication, something just frequently used in machine learning. For these kinds of operations, Apple said it made the A13 6 times faster than the A12. This year, they're saying it makes the A14 10 times faster than the A12. So, plus, minus, whatever, 4x faster. Yeah, true facts. All this math stuff is why my shelter-in-place sourdough starter just never started. Anyway, again, A14 Bionic really just means the next generation of pretty much all of Apple's silicon IP. And yeah, they use the term IP to refer to cores and blocks in silicon as well. And Apple's philosophy, their MO so to speak, seems to be moving the whole chip forward, all the IP forward, every generation, year over year, to leave basically no corner untouched. And a lot of that is informed by the silicon team staring, just straight staring at what kind of apps people are using, both Apple apps and App Store apps, what the OS, the operating system teams inside Apple are planning for the next few years out, and what sorts of apps and workloads seem to be coming onto the market, or at least the ones they expect to be coming on the market, the trends they're anticipating. And that results in things like, yes, the beefy caches, but also things like the Pro Video encode and decode blocks, which the A-series chips use to handle H.265 video. And they do it so well that Apple actually redirects it away from the Intel chips in current Macs and towards the T2 chips, which are variants of the A10 with those blocks. Also things like the performance controller, the secret sauce that figures out what to direct to the CPU, to the GPU, to the ANE, and to the other components to get the best performance at the highest efficiency for just any given task. And that new ML controller, which does the same thing between the Apple Neural Engine, the AMX, and all the main cores. Also things like the custom storage controller, which isn't just about having the solid-state chips performing as fast as possible, but making sure they're capturing every photo, every frame of video, right and properly saved, which really doesn't sound like much, I get it, until you hear people with other, even recent generation flagship phones complaining they're missing pics or just dropping frames. And it's not as flashy. I totally get that it's not as flashy as a lot of the more gimmicky things that we see in big launch demos these days, but it's the kind of thing that helps real people avoid real problems and just have a better experience day after day. Same with things like making sure video encode and decode and video capture don't just perform, but sustain. Because if you can't record that 4K 60 extended interleave dynamic range video for as long as you want to, again, without dropping so much as a single frame, that feature just simply won't be as useful for you. Which is why when we get numbers like 20% more performance, but also 40% greater efficiency, that's not just the result of a process shrink or some big lever being pulled that cuts something off somewhere. It's the result of touching all those corners of the silicon, of working on all those IP, of shaving off a 1/10 of a point here and a fraction of a point there, of every tiny advance helping push the overall performance and efficiency forward. Like, never mind death by 1,000 cuts, life by 1,000 cuts, to totally just mangle that cliche. Because again, counterintuitively, efficiency is ultimately performance. And I know, you know, I know that you know that I know. Every year, someone looks at the numbers Apple posts or gets sucked up by Geekbench and how the iPhone or the iPad Air compares to or even beats this or that laptop, even MacBook, and wonders out loud if we really, really need this kind of performance on a phone or a mainstream tablet. Or conversely, we get reviewers looking at brand new devices launching with older silicon, maybe a year, maybe more, and saying it's fine, everything's fine, it does what it needs to do, everything is snappy enough, so everyone should just quit worrying and complaining about it. And yeah, both those things are when I start screaming, because most people keep their phones for far longer than industry analysts and reviewers, for like 2 or 3 or even more years, and their tablets for much longer than that. So it's less about how something scrolls or feels snappy on a brand new device the day it comes out, and more how it will keep scrolling, keep feeling snappy, keep performing in general the next year, the year after that, the year after that, when they've used it more and accumulated more cruft, when the operating system, the OS, has been updated with new features, features that make greater demands on the silicon. And honestly, that they can even keep getting those updates, those new features and new security patches both. Apple, has said pretty damn directly that a lot of the overhead they build into the A-series chips is not because of what they're doing now. This year with like iOS 14 and iPadOS 14, and sure, macOS Big Sur, but because of what they're planning to do next year and the year after that, for around the 5 years after that, and what they envision apps will be doing and what we'll want to be doing with those apps. Also the updates for both features and security that we'll still need to be getting. And that way we maintain as much of that day one experience as possible on day 1001. And there'll be bugs for sure, and battery drains, and all sorts of frustrations and failures along the way. And they'll get fixed, and they'll get broken again. But the overhead in the silicon means we'll have the absolute longest possible runway to get the absolute highest value out of our iPhones and iPads possible. And that's true now with the A14 Bionic at 5 nanometers, and it'll be true with the A16 or whatever at 3 nanometers, which, to be honest, is a tiny size that kind of just melts my brain a bit. Like PIM particles, like quantum realm, like Doctor Strange T-trip scale brain meltage. Because reckoning with infinity is like something you need major math to deal with. But you can start with Brilliant and their new Infinity course. Because of course you can start with Brilliant. Brilliant will take you from basic counting and work your way up to the many types of infinity, culminating in the profundity of Cantor's theorem, exploring the stunning beauty of fractals, where it's just turtles, or I guess chipsets, all the way down, and tessellations in hyperbolic space, where the infinitely large is bounded by a simple circle. You see, Brilliant's a website and an app with over 60 interactive courses in math, science and computer science, logic and deduction, physics, quantum mechanics, game theory, cryptocurrency, and so much more. It's based on problem solving and active learning. It's about seeing concepts visually and interacting with them, and then answering questions that get you to think. But there are no tests and no grades. You just pick a course based on what you're interested in and get started. And if you make a mistake, literally nobody cares. Nobody. You just check out the explanation, find out more, keep going. Go to brilliant.org/ReneRitchie and sign up for free. Just click on the link in the description or go to brilliant.org/ReneRitchie. And the first 200 of you can also level up with 20% off the annual premium subscription. And clicking on that link just really helps out the channel. For a ton more on the iPhone 12, iPad Air, and everything that's coming this fall, click on this playlist right here. I'm going through every new feature and what it all means. So click on the playlist, and I'll see you next video.